had a saw in their hand, and they design really awful things. Because it's not because they're stupid, it's just because they don't have the real life experience. You know, it's like, we're gonna 3D print a house. Okay, well that'll take 5 years and cost $1 million for an 8x10 shed. Great, that's not really a good use of your time. Or they build mechanical structures that, you know, like this mechanical structure here. It had 2 long bolts hanging down here, and these motors would kind of hang down from there through 2 long bolts. Well, the whole darn thing, when you started putting pressure on it, would start twisting, which is why we designed it like this, so it's completely enclosed. But that's stuff you only get from experience, you know, with using that. When we talk about makers, we're not just talking about tech people, not just computer people, not just doctors, not just whatever. You gotta take all different areas. I mean, sewing, I mean, look at it, you have automated CAD/CAM sewing stuff to do embroidery, the automated embroidery machines, right? You have your design, you put it on. Now it usually ends up sounding better than it really is, because it does take more work than just go, but any skill does.
I want to finish up, if
Sure.
you don't mind, put it back into the real world and the medical world. And the top part of it said we've already got done. The hardware part, the brain power is probably not done. But anyway, with the Raspberry Pi, which is a real computer, it's $35 this big, it drives the camera, which is about a $30 camera. The camera is the same camera that's in your cell phones. So it's a very powerful little camera. It will do a lot. Anyway, the bottom line is with the camera there, you can project it, like you were asking, on the wall.
Yes, sir.
The Raspberry Pi is Bluetooth and Wi-Fi. You can put it over the internet.
Right.
So there's a lot of power with it. It will also, and this is where the brain power comes in, and we haven't tackled that yet, but in the world of computers, there's another thing called computer vision. The computer can recognize her face or can recognize your fingerprint. So that's how the FBI uses it as a fingerprint. They can tell your fingerprint from millions of other people. And you've seen it on TV, how they scans it. That's called computer vision. So you can use this system for the same thing. You can use it to not make diagnosis, but it can give you the perspective or a tentative diagnosis. So to some extent, you'll have a physician's assistant or a technologist, whatever you want to call them, and that's what they use for the pap smears. So all the pap smears that are done on women, a technologist reads them. Then when they find one with a certain grade, they will give it to the pathologist, and he decides if it's cancer or not. But all the screening now could be done with this. Now, in the real world, again, back in 1970, I think it was, I was in Arizona, and NASA was doing a project there with Papago Indian Reservation. It's an Indian reservation that crosses the border between Mexico and Arizona. Very little medical care. So what they did is they set up this project there of a microscope and an x-ray, and then they would send this up to the big hospital in Phoenix or wherever in Arizona was tied into the thing, and then they would make the diagnosis there. Okay. So that's now called telemedicine. We have a fair amount of it in this area. Scott White, our hospitals here, emergency room, I think Metroplex uses telemedicine. The doctor is in New York City somewhere on call. So anyway, as you move forward then, from there, right now we have a female astronaut in space, in the space station. Just went up 2 weeks ago. And what she is studying is the genetics of the DNA in space. But related to 3D printer, they're also studying now telemedicine, because again, what I'm talking about the Papago reservation was research for the people going up to the moon, for the people up in the space station to diagnose it when they have a runny nose or cough or whatever. They just can't come back. It takes them 2 days to get up there. So anyway, what she is doing is studying things in what we call no gravity. So she's studying how to do the DNA in no gravity. The same with the 3D printing. If they have a part break up there, the bottom line is that they might not get one. The next rocket may blow up. We've had two of them blow up with millions of dollars worth of equipment. They might have to wait a long time. Now the engineers down on the Earth can send the dynamics, the drawings, or whatever they need, the part up to them, and they can print it. So now they're trying 3D printing in space where there is no gravity. So ours come down like this here, so you have to have gravity to do 3D printing. So anyway, the bottom line is all this is being researched and used in a lot of different fields. What we're trying to do is to bring it down. And for example, a lot of the stuff that I learned and did research in medicine, this was my area, research in medicine. The first fetoscopy video looking at the baby inside the uterus I did. The first laparoscopy, what we call belly button surgery, the video recording of it, I did also. So my field of developmental research was in optics and electronics combined. Now, back then, laparoscopy wasn't done. Now it's one of the most frequent operations done by surgeons, OB/GYN doctors, and so on. All thanks to a certain group of doctors that formed, AAGL, did all this research and then passed it on to other people. And most of it was done for free. Or they wanted their name on the device. Doctors like a lot of people, the clips to clip the fallopian tubes. I know 4 or 5 doctors, a whole clip, the Clevenger clip, just to clip the tube. The doctors were designed for the companies.
Did they put their name on it so you could just etch it on the side of the clip?
Yeah. No, but it was known by that. I used a whole clip. Dr. Olker from Duke, I was using a whole clip.
Well, and the other thing about this project, I don't have any great love for microscopes or thing. I've never been a biology guy. I mean, I got dragged into it because of Dan. But what is interesting for me is the integration of different stuff. You know, taking this, taking that, and that's where it's important. Yeah, look, okay, you could say to yourself, I don't care about microscopes or whatever, but think about in your own lives problems that exist that could be solved with using these array of tool sets. Used to be prohibitively expensive, and now it's not.
Along that same line, Roy and I have been working about 2 years on this now, astronomy. And it's a very steep learning curve. I need 2 or 3 telescopes. Last night with our team, we had a couple of teams there, Roy and I. It's the first time that we got to the point where everything that we talked about here, now we can do with the telescope. So we zeroed in on Saturn, and then with all the brain power built into the, other people built it into the programs and so on, I can say I want you to go to Spica, I want you to go to Vega, the star in the sky, whatever, and the telescope is connected to the computer, and I click on the computer and it goes over there. Or I want it somewhere else, and it goes over there. So it took us, wasn't it 2 years, right? Almost 2 years to get to that point. And that's already done. The research is done, you just buy it. I'm saying the brain power to make this stuff work is, to me, very essential if we're going to keep up with the Russians and the Chinese. Our female there that went up to space just 2 weeks ago, she spent 2 days in a Russian rocket going up to the spaceship. When she comes down, she's going to land in Russia, not the United States. I think we really need to think about why that's happening. We need to start getting this to our kids. Making a kit here, for example, where the teacher, once one gets it out, we lay out the prints, we lay out everything, and all they have to do if they're interested, and again, somebody's got to motivate them, money-wise, whatever kind of motivation factor and so on. But that's what we're trying to do, is get it so it's easy for somebody to do. Say, we don't want to take 2 years for them to be able to do this.
And the students are eager to learn. The
Pardon?
solar cars, the things they're putting in the schools now, even the little personal computers or iPads, they're eager to learn.
Now, the telescope thing, you said you focused in on, you told it to go to Saturn. Well, where's the starting point? What do you focus off of for a standard so it knows which direction to go?
Well, first of all, we've got a free software program that we're using. I also have one I bought called Stellarium. It's got the whole sky in it, time, dates, and so on. So we can tell where every star is in the sky, or every planet at its exact time.
You would need to know your lab, your elevation, and you usually point it to like a guide star to start it out with.
Yeah, you gotta have a starting point.
Right, but the cool thing is that some of the even newer scopes will have basically the brains that are built into a cell phone. Cell phone has GPS, so you're accurate down to less than a meter. It shows you your elevation. It's got a compass built in, right? So if you put the brains of a cell phone into a telescope, the telescope now knows which way it's pointing, it knows where it's located, and it knows the exact time based on GPS.
Okay.
And then every motion is mathematically determined. So once it knows exactly where it is, and then it drives itself with good old stepper motors. Because it knows that if I step 10 times, I'm moving this amount. Yeah,
We started last night.
yeah, it's really cool stuff.
When I see Saturn up there, well, we could use any of the planets, or we could use any star. But we do what is called a one star or one alignment, one thing. Saturn itself. So when we go to the computer knows exactly where Saturn is. So when I tell the computer, this is Saturn, lock in on it. We're locked in on it. From there on, it knows everything
Yeah,
else.
I can see.
So
that.
yeah, so that's the one. So with Dan's thing, he's spotting something he knows, and he's telling the computer, "This is what I know," and we're aimed on it. But now, like you're saying, the new Meade, the Meade telescopes,
There's a new one called Meade, light switch.
light switch,
But
which has
that
this.
only does, well, yeah, it does alignment too. The new one
Yeah.
has got all this hardware and brain power built in it. It levels the scope. First of all, the scope has to be absolutely level because 90 degrees has to be straight up there. It levels the scope. And then it goes to your GPS satellites. And that's something we probably should cover sometime here. Because most of us couldn't live without the GPS satellites. Okay, they're all over. And we're not the only ones. India's got them, Russia's got them. So it's going to be a major problem to the military. But anyway, it takes the GPS, it gets your latitude, your longitude, exactly where I'm standing on this earth. It knows the exact time by a standard time, time that we might be using, not central daylight time, so on and so on. And then it does this alignment. What they have is built in a camera. So the camera looks through the sky, and most alignments will go with what they call, there's 200 bright stars. So it'll find 3 bright stars, and then in its brain power, it says, that's the summer triangle. Okay? That's Vega up there, that's Deneb here, that's Altair there. Everything fits, just like we talked about computer vision. Looks at your face and says, well, you're not her. You know, then it looks at the database and says, well, I know Dan Kahn, that's him. So it says that's the summer triangle. And from there on, it's off and running. You don't have to do everything that we do.
It's pretty amazing. What would have required a tremendous amount of expertise now gets built into the devices, which is good and bad, right? I mean, smartphones got to make us dumber in some ways.
Yeah, but it sure simplifies things.
Right, exactly. Well, and that's the nice thing about that automation is that it lowers the bar to entry. Like Dan was saying, instead of having to spend 2 years learning how to spot stars, you can get kids and adults looking through a scope and finding things almost instantly using the technology, and then it gets them jump started into it versus getting frustrated. Because how often, you know, somebody's trying to learn a new thing like woodworking, and then you smash your thumb with a hammer and you want to give up on it. Same idea, right? You got to keep going.
And that's the same thing that we're doing. Most people who want to get a telescope, they want to look at the magic sky, okay, the wonders of the universe. They don't want to spend 2 years trying to find something. With the new ones, you just push a button, and you're looking at Orion's Nebula. Basically, we all came from that nebula. All hydrogen, all helium and so on, and from there on down, everything iron. The bottom line is, it looks
Oh, right.
a certain thing in space. And you probably have all seen the Pillars of Creation picture, anybody? 3 pillars.
From the Hubble.
Yeah, anyway, there's nebulas up there, there's clusters up there, there's things that people want to see. They're beautiful, they're unbelievably beautifully colored and so on. But you don't want to spend 2 hours trying to find it in the sky.
By that time, the sky, we moved and it's out of view.
Well, yeah, that's the other thing. Before we got to tracking, when we got to the moon, you've only got about less than 2 minutes to look at the moon and photograph it or video it, because it's gonna go. And
Right.
it doesn't go this way and this way, it goes like that.
Yeah.
So when you're working, it's like the
Well, yeah, you,
Xbox controller, you've gotta go this way, you can't go up and down, so you've gotta, in your mind, and Roy can tell you, anything in optics, the first problem you have is everything is up and down and right and left. So somehow, in your mind, you've got to start solving both problems right off the bat. Everything right is now left, up is now down. So, now, with software and hardware prisms, you can change that. So, but a lot of astronomy people do not. So, but anyway, that's what we're trying to do, is get all this brain power spread amongst the common folks. Thanks to Rob.
well, yeah, thank you.
You have the program on your phone. I don't. I thought